And now for our final video on exponents. We're going to talk about the power rule. More specifically, this is the power of a power. In other words, we'd have something like this. If you see this expression, this would be a cubed to the second. In other words, a to the third power, the whole thing to the power of 2. So power of a power. All right, so let's figure out how that's going to work. Let's first look at what's inside the parentheses. Right? So we would just say a times a times a. Well, then we're going to take the whole thing that was in the parentheses and we're going to multiply it times itself. A times a times a, right? In other words, first we say a cubed, then a cubed times a cubed. So when we put that all together, we've got 6 a's multiplied times themselves, right? So we've got a to the 6th. All right? Well, let's look at this next one. Now I've got b squared to the 4th power. Again, let's work it out. First, I've got b times b. Then I've got another b times b. Once again, b times b. And finally, b times b. Well, let's see. We got 8 b's multiplied times each other. So that makes this whole thing b to the 8th. Last one, we've got c to the negative 1 to the 3rd. Okay, well, once again, c to the negative 1 is just 1 over c, and we do that 3 times. 1 over c, 1 over c. Well, that's 1 over c cubed, but another way of thinking that is that's c to the negative 3rd. Well, let's see where we got these exponents. Well, sure enough, look, here's a 3 and a 2, and you get a 6 by saying 3 times 2 equals 6. Here, I've got a 2 times a 4, which gives me an 8, right? 2 times 4 gives me an 8. And then finally, let's keep this separate, I've got negative 1 times 3, which gives me a negative 3, right? So negative 1 times 3 equals negative 3. So that's pretty cool. Look, we've got ourselves a new rule. In other words, b to the m, the whole thing to the n, means you take b to the m times n. Right? And remember before we weren't multiplying exponents, we were doing things like adding and subtracting them. So this is a little different, isn't it? Okay, so let's just try this out on a few problems. Okay. First one is, all right, this guy right here. So I've got d to the 5th power, whole thing to the 3rd. Well, all I have to do is just say d to the power of 5 times 3, which is just d to the 15th. For the next one, I've got e to the power of negative 7 times 2, right? Which is just equal to e, once again, e to the power of negative 14. And finally, let's look at this guy here. Look, this time we've got 2 negatives, don't I? But that's okay, we know what to do. We just say f to the negative 6th times negative 3. Well, 6 times 3 is 18. Negative times a negative is a positive. So this is just f to the 18th power. F to the 18th power. Hey, I do want to take a quick second before we move on to the other problems, though. Talk about formatting. One thing you might notice here is when I start having negatives, it really does help to put some parentheses around things. Just so we're really clear. And also, don't get dots confused with minus signs. That was a little sloppy. Let's make that a little more obvious. If in doubt, use some parentheses. One other thing, too, you can do, I'll just pull out a keyboard here for a second. You can use the up arrow to represent an exponent. So, it's easy when we've got it on a piece of paper, right? But if I have to type this on a computer, for example, if we're doing an IXL, you're probably going to want to use a little shortcut, and that shortcut says this. For f to the 18, I could have typed that on a computer by saying f, and then I would type the up arrow and the 18. And depending on your program, that will actually automatically, in a lot of programs, that will automatically rewrite that as f to the 18th. So that's just a little shortcut because a lot of times we don't have, of course, if we're typing, or if you're like writing an email, you know, exponents aren't always that easy to type. So this is just kind of a handy little thing. Sometimes people use an up arrow. And sometimes literally it will just reformat for you. It's pretty cool. Okay, so let's keep going. Now let's talk about the situation where I have different bases. If I've got different bases, same kind of thing. It's almost like you're distributing it across the parentheses here. In particular, right, this fifth power applies to both g to the third and h to the negative 2. Now again, g and h are different bases, so I can't just sort of mush them together. But I can essentially distribute that 5. Again, technically this isn't the distributed rule, but I'm just saying it kind of looks like it. Okay, so let's do that. This would be now g to the power of 3 times 5 times h to the power of negative 2 times 5. You know what? I think I'm going to do those as parentheses just so there's less confusion. Okay, right? And then I just work it out and I get g to the 15, h to the negative 10. Okay, now again, that's as much as I can do. I can't mush these g and h together in some way. I'm done. That's as far as it goes. Okay, so g to the 15, h to the negative 10. Okay. All right, let's look at another example. Right here, where I've got j to the negative third, now this whole thing to a negative power. Now again, we got a bunch of negatives here, so again, we got to be really careful on this. And again, I strongly recommend you don't try to do all this stuff in your head. Do this on a piece of paper. Be neat about it. Make sure you're getting this right. So I end up with j to the negative 3 times negative 2. K to the power of 4 times negative 2. Right? Notice the negative 2 gets multiplied times both. And so this just becomes j to the 6th and k to the negative 8. Right? J to the 6th, k to the negative 8. Again, can't keep going. Can't do anything more to that. J and k are separate bases. I got to stop there. Okay, but that's good. I've now simplified this whole thing. Okay, all right. So now we've gone through a lot of different rules for exponents. Let's kind of summarize them here, and we really need to compare what's the same and what's different. Okay, now in particular, look what happens here. When I had b cubed times b squared. Remember, think back for a second. This is b to some power, b to the power of 3 plus 2. Right? I'm adding the exponents. So that means this is b to the 5th. Right? Remember, I've got 3 b's times 2 b's, so I'm multiplying 5 b's. This time, I'm dividing. Let's look at what happens if b to the 3rd divided by b squared. Well, that's just 3 minus 2, which is just b to the 1st. And you could even just write that as b for that matter. If I've got a power of a power, right, this means I've got 3 b's and another 3 b's, which means I've got 6 b's, right? So in other words, this time I'm saying 3 times 2, b to the 6th. Okay? It's almost like we're kind of going down a level in what we're doing, right? Here, I'm multiplying the powers. That means I add the exponents. I'm dividing the powers. I'm subtracting the exponents. I'm doing a power of a power, and I multiply the exponents, right? So this is something you'll get better at as you do more and more problems. But this basically wraps up what we've been doing on exponents. And it's been a lot of fun going through these videos with you. And looking forward to our next topics. And we'll see you then.